Good evening. We'll call this meeting to order. We have quite a bit to cover tonight, so we want to use every minute.
Here.
Moser.
Here.
Schramm.
Here.
Weber.
Here.
Mayor Johnson.
Here.
City Manager Leon.
Here.
City Clerk Decker.
Here. Well, thank you everyone for being here this evening. Now's the time for public appearances, so if there's anyone in the audience who would like to address the commission about something not on this work session agenda, now would be the time. Seeing no one from the public here, we'll move on to the main event, which is a FEMA update as well as a wastewater treatment plant conditional assessment update. City Manager Amy Leon, if you could introduce these two subjects for us.
I feel like I should say, let's get ready to rumble. We're here this evening to give you a brief update on how we're going along with the FEMA process in general. And most of the time, we're going to have Kyle Goodmanson, our Director of Environmental Services, and our guest, Nick Van Wy from HDR, talk a little bit specifically more about the wastewater system in terms of damages, the repairs that need to be done, and the conditional assessment. It wasn't entirely clear, that topic wasn't entirely clear when we started out with this plan, but after March 13th, it kind of even became more complex. So there's quite a few layers here, and we don't expect that everyone's going to digest every detail this evening, but just to start to wrap your arms around all of these things. So as we're thinking about this, as time moves forward, we need to think about repairing damage, of course, the financial costs involved in that, as well as planning for the future and how much we want to do or how little we want to do based upon the knowledge that when we go into the long-term future, we'll be changing probably a lot at the wastewater plant, whether that means entirely new systems or upgrades and renovations or maybe even considering relocation. So we have to keep all those things in mind, but still address short-term needs. So they're going to be starting to introduce that topic. We'll try to leave some time for questions and answers, and then we're also going to try to quit a little bit earlier than we typically do so we can take our commission picture before we go into our regular session. So with that said, I want to give you a little bit of an update on where we are. Many of you know that our first deadline was a 60-day deadline with FEMA. We have just under 30 of those days left. And unfortunately, the individual that we were working with got sent back to his home office, which is Hawaii. So we were reassigned a new local coordinator who is, I believe, from Pierre, but working out of the Sioux Falls office. His name's Gary Hartman. So he's just now starting to look. We met him last week at all of our damage and all of the documents that we have. And we're working now through him. So I don't think we took a step backwards in the sense that we have all the information we need to complete our damage assessment, but everybody does things a little bit differently. So he adequately probably described it when he said ducks look on the water look like they're just floating along, but underneath they're really pedaling their, what do they have, flippers? Feet. I don't know. So we're a little bit stressed out, I would say, upstairs, and we're working as much as we can. We think in terms of the police firing range, I think that's pretty much assessed, meaning I think we have that all documented. We're now working through the parks damage. We have some deadlines on the wastewater plant and Marne Creek, which are Friday at 5, so we're going to be kind of all hands on deck. Mr. Hartman will be down tomorrow. And we're putting everything else that's not a top priority on the back burner until we can get things submitted. So the damage assessment is really just a listing of everything that was damaged, along with what insurance will cover, along with the hours associated with fixing that or the hours associated with addressing that. We haven't even scratched the surface when it comes to the broader picture of what the long-term fixes will be for the creek, although we do have our initial report now from Stockwell Engineers to work with to help us with that damage assessment. So I don't want to talk out of my wheelhouse, so I'm going to hand it over to Kyle and Mr. Van Wy to talk to you a little bit more about the wastewater plant. We do have a PowerPoint, and we were working on that up until this afternoon, so I don't believe you have that in your Dropbox, or excuse me, in SharePoint. I'll double check when I sit down, but I'll hit the lights and let them give you an overview. So thank you.
Good evening, Commission, Honorable Mayor. Thank you for your time tonight. Like Amy said, we're working through the whole process right now of going through all of our options with FEMA and now with the EDA. So we're just kind of working through that. So a lot of this is kind of dealing with the condition assessment, and a lot of it is dealing with the EDA application. Just kind of a little bit about what the condition assessment was, the overview, the process, and some of our findings and recommendations. Again, we're not fully done with the condition assessment yet. We're still working through that. But again, we moved into more of a preliminary engineering phase for the EDA application. Key staff, myself, we also have Tanner Hansen here tonight. Then with HDR, we have Nick Van Wy here. And then Delron Peters and Dan Graber have been the main two working with us on the process and going through the condition assessment. The other engineers are specific to certain areas, whether it's electrical and structural and things like that. Again, key issues that we've been seeing at the wastewater plant, the main one is aging infrastructure and declining reliability with our system. We did make it through the March flood fairly well. We didn't have a lot of damage, but it did open our eyes to a lot of areas where we need to make some improvements. And then also, anytime you're looking at improvements, you're looking at those future regulations and policies that'll be coming down in the future. The process, again, it's kind of evaluate our goals, objectives, evaluate the information, set some priorities, look at alternatives and options, and really come up with a plan. And that's kind of where we're at in the process right now. Is we've gotten the basic information. Now we're starting to put together a plan. When you look at prioritizing issues, the biggest one is what keeps Tanner up at night. I sleep just fine because I know I've got Tanner to answer his phone. So, but that's what keeps the guys up at night, and those issues that are always in the back of our mind. And again, performance, we're always looking at ways that we can optimize our performance to save money in the long term. Being proactive, maintaining a good maintenance program so that these facilities are resilient. And then, of course, one of the things we're seeing more is now, as we're seeing a lot more, is as people retire and take a lot of this information with them, we need to do a better job of planning and getting that information documented and developing some standard operating procedures for things and to deal with them in the future. What's really driving these capital improvements? Again, the regulatory requirements are always in the back of our mind. Flows, loads, capacity, looking at where our system is in terms of capacity. And then the facility's age and condition, and that's still the biggest one. Process equipment is probably the biggest one where we're having some issues. We do have some structural issues with a few of the buildings. We have some electrical issues that we think we can add some resiliency to our system. And of course, we're always looking at safety issues. Right now, the biggest, like I said, the biggest thing again is we're at that lifespan for a lot of our equipment. We're years past it actually. So that leads to increased numbers of failures. Some of these pictures, like the top right, you can see where we have a coating system that needs to be replaced. Below that, you see a pipe that's got a stainless steel band on it. That's a pipe that's failed, has a wraparound band on it. So we're starting to see those failures in equipment that need to be addressed. Kind of how we got to where we are now. If you kind of remember, as we were going through the budget process, 2017, 2018, we had a lot of issues at the wastewater plant. It seemed like we were constantly fixing things. We weren't really getting ahead of things. So we started talking about, in our capital improvement plan, budgeting for a condition assessment. And we actually had that scheduled for 2020. Then the flood hit in March of 2019. If you remember, then we came to you shortly after that, and we talked to you about moving it forward with the condition assessment at this time. Main reason was to address some of the issues we had at the plant and to be ready for the future funding options that were going to come out, mainly the EDA. Here probably a couple months ago, we got notification of that EDA grant. And then when that came out, our condition assessment really shifted towards identifying EDA projects. What came out of that then is preliminary engineering reports to be put into the EDA application. The application for the EDA is really looking at projects that add resiliency to your system, so that when those natural disasters hit, your system can withhold those, handle those, and you don't have as many issues. So that kind of where we got where we are today, and that kind of led into the projects here. We've got about 16 projects that we're looking at right now. First one here is to replace the electrical main gear. This is basically our electrical gear that switches during our power switches. So if we lose power to the plant, the electrical gear has to switch over to the secondary power supply. We've had some issues with this. We had a brownout one time because the transfer switch did not work properly. Brownouts is when you lose basically one phase of your power, and then that causes more damage within the plant. This is, I believe, 2000 was when it was originally installed. Switchgear is actually 1980. So again, it's beyond its lifespan, so we're looking at some options to improve that. We got an estimated project cost of about $700,000. Again, these are preliminary costs, preliminary engineering reports, so we'll continue to update those as we move forward with EDA. The second one is reducing single points of failure with our electrical system. If you kind of look at our electrical system right now, it's basically one feed goes all the way through the plant. So if you lose that feed in one spot, you may lose it to 3 or 4 buildings. So we're looking at a system where we have separate feeds going to each building, not only for resiliency, but also as we get into future projects where we'll be updating some of these things and wanting to take certain things out of power. We don't want to be just when we take one building out of power, losing power to 3 or 4 buildings. So this will add some redundancy in our electrical system. Next one, if you remember, as our last EDA project, we put in some effluent pumps during that project. For several years, we've had a generator in the budget. We haven't purchased it. It's always one of those things that gets pushed. Through this, we'll apply for a generator to power these pumps. If you would lose both power supplies to the plant, this would allow us to run a generator to pump the facility, the flow away from the facility, and prevent damage to the main infrastructure in the plant. The generator would also be able to be used at other locations, including the booster stations and Nebraska wells. Again, estimated project cost of roughly $521,000. Pre-treatment room influent screens. So this is the screening mechanism for the initial flow into the facility. We've had a lot of issues with our pre-treatment building, so we're looking at making some improvements to that. It's one of the first things that showed up on the condition assessment in terms of needing repairs. Get about $530,000 for cost and improving that screening system. Replace pumps with dry pit submersibles. These are, that picture to the left there is a really bad picture. That's exactly the same location basically. In the past we've had this basement flood. These pumps are the main pumps. Everything gravity flows to these pumps, and then they have to pump it up through the rest of the system. So if they fail, we lose everything. Currently, the way it's set up, if you look at the pump to the right, it has a motor on top that's not enclosed. So if that basement floods like that, basically you lose the motor and you're down for days, if not weeks, to get that motor pulled out of there, overhauled, and everything back in. What we're looking is replacing those pumps. Again, they're 20 years old. They're at their life expectancy with what they call a dry pit submersible. It's a pump that's designed to be underwater. It'll run in a dry pit, but it's actually could run submerged underwater. So if we lose that facility again and have that flooding, we don't lose the motor. You simply get it pumped out, flip it back on, and it runs. So it adds a lot of resiliency to your system, and you're not down near as long as you would be with our current infrastructure there. Again, estimated cost for those to replace those 3 pumps, and that includes removing some of the electrical that's down below and moving up to an upper level so it won't be flooded, around $456,000. This is kind of a newer one for Tanner and I, electronic operation and maintenance manual. Currently, we do everything through Excel files for recording our maintenance and our operations. This will really be the first step in getting our plant into an asset management style system. It gives us a better way to track our maintenance, track our costs, and determine where we're spending money in maintenance and operations and where we can save that money. That's looking around $250,000. This one, like I said, is a little bit newer to Tanner and I. We haven't had a lot of discussion with HDR, but it's definitely one that we're interested in. New equalization basin with pumping. Right now, when we hit our peak demand, we basically have to force the water through the system, and it overloads us hydraulically and causes us issues. What we're looking at is basically adding a basin out in Paddle Wheel Point, in the same area as our sludge lagoons. And what this allows us to do is basically have roughly 1 million gallons of empty space to divert water to during these major events. This last event, I'm not sure if that would have been enough, because we figured we bypassed roughly 3 million gallons during that event. But for a lot of events, we would be able to equalize, send some of that flow over to our equalization basin, and then bring it back at a later time. And then it also helps during our day-to-day operation. Currently, right now, we have real high peaks during the day and real lows at night. So on a daily basis, we could actually send some of our flow during our peak hours over to the equalization basin and then bring it back through the night. When you're working with a biological system, the more even keel you can keep everything, the better it is for the bug life, and the better your system works. Roughly $1 million. We looked at potentially using the area where the lime lagoons were at, but decided it'd probably be better to move it over towards Paddle Wheel Point. Add some cost, but in the long run, I think that's a better location for it. Service bypass gates. One of the things we realized during this last event is a lot of our bypass systems are not up to where they should be. We're used to bypassing off, I shouldn't say we used to, but we've bypassed off the primary treatment several times, but we've learned that our bypassing system right at the Influent building isn't really operational. We need this, again, for events, but we also need it as we move into doing some projects within the facility when you're going to be taking buildings out of commission to do repairs and things. We're going to need that ability to bypass. So you want to come in and basically overhaul our bypass system, our bypass gates, and get everything up and working, so as we move into future projects, we'll have that system working properly. Secondary splitter, influent pipe. This is the sinkhole that's up on top of the hill. This one's still a pretty gray area too. Right now we have it in the EDA application. We're not sure what FEMA is going to cover. And then there's also the option to run this under a FEMA mitigation project. So this one will continue to keep all of our options open as we work through both the FEMA process and the EDA process. We got a preliminary cost of $1.4 million, but this also includes some other issues we found out during the project. As that sinkhole and the material disappeared, it also took all the other pipes that go into that building settled. So all the pipes that are coming into the building now are coming in at really funny angles and are putting a lot of pressure on the piping system within the building. So when we have it excavated to redo that 36-inch pipe below, we're also going to be doing work on all the other pipes to bring them up so they're level and we're not putting that pressure on the piping on the inside of the building. So we're also looking at, since we're going to have everything down, all the bypass pumping in place, there's a wet well in the basement there that will, since we're going to have it out of service, we'll be doing a new coating in that wet well to prolong its life. Again, some of this project may be FEMA, some of it may not, we're not sure yet. Influent this is the influent pipe from the new manhole to the plant. If you remember, during the force main project, we installed a new manhole, basically kind of there by the street shop. And then a year later, we had a failure in the manhole on 2nd Street, up in the intersection. Then we basically replaced that manhole with 2 new manholes and piping out into 2nd Street. So this again is an arched concrete pipe that we've had failures on in the past. We've had failures with the manholes. So part of this project, we basically replaced the pipe going from the just north of the street shop all the way down to the inlet building at the wastewater facility. So that's kind of where we're at with that one. Estimated cost of $1 million. Again, it's a project that will add to that resiliency for the future. Our bypass pump, this is something we're going to put in. As you can see, it's an older piece of equipment. It worked very well the night of the flood. Tanner uses it quite a bit through his day-to-day operation, and I shouldn't say day-to-day, but in his operation for moving material around from different solids, lagoons, and things like that, or if we have to take down a primary clarifier, this is the pump we use to pump it down. Again, it's just aged. It's past beyond its life expectancy, so we'll look at replacing that. $84,700 is, again, a preliminary cost that we have on that. Manholes. During the event, we had a lot of inflow into our manholes. We've got some areas where we know these manholes are in ditches, especially out by the Hastings area and the area around Bill Baggs Road. They're lower manholes. They get covered with water during events. It's to go and rehab those manholes and make them watertight so we don't get as much infiltration. Controlling the infiltration, again, keeping the water out of our wastewater system will keep it from having to treat it at the facility and pump it through our lift stations. An estimated cost of $20,000, not a real expensive project, but a very important project. Now we kind of get into some of our planning documents. As part of this too, as the ED application, planning documents are something that we're eligible for cost. We've been talking about the GIS water and wastewater for a few years now. We've kind of been struggling to get the manpower to get it done. So this would give us an option to come in and hire somebody in to come in and do shoot in all the manholes, all the piping, all the water distribution valves, fire hydrants, and everything. Estimated cost $250,000. Again, this is something that's kind of been in the budget, and we just haven't got to it yet. So we'd like to be able to move forward with that. And that is also very important in terms of getting our master planning done. The next step, as we move forward with this condition assessment, is we'll complete the condition assessment, which is still probably a few months out yet. Like I said, we push more now into preparing for an EDA application. The following step after that will be the master plan itself. And that'll just take it to the next level and begin to prioritize those projects that are out in farther years, identify a direction that we want to go in terms of is this a larger project, is it a bunch of smaller projects, and how we're going to move forward with those. And then the next big one will be the wastewater collection system master planning. The wastewater master planning in the collection system is a little more complicated than I would say on the water side. The first part of this would be a lot of modeling, following up. After the GIS, we'd go into a phase of modeling. The tough part about wastewater is it's very hard to predict what you're going to have. On the water side, you can shut a valve and see how that reacts, how your system reacts. You really don't have that ability in wastewater. So you really have to wait for the next event to really see how your system reacts and to make sure your model works. So you spend a lot of time collecting data, you put samplers in your system, you collect your flow data, you develop a model. Then based off that model, now you have to go back and calibrate your model to make sure it really does what the system shows. And then you need those infiltration events, those events that cause that infiltration, to see if your model really is working and how much it needs to be calibrated. So that usually ends up being a several-year project to get just the modeling done on your collection system. That'll give us a better idea of how much infiltration we're getting into the system and where that infiltration is coming from. In the past, we haven't had a lot of issues with infiltration. We've noticed in the last 2 years, our water table's higher than it's ever been in Yankton. So pipes that were never underground are underground, or were never underwater are underwater now because they're in the groundwater. So it's going to make some unique decisions. One option is to go in and try to reduce that infiltration. The other option is to leave it alone and just treat it at the wastewater plant. And it's going to be a really hard decision for us, because is it going to stay this wet? Are we going to continue to have these infiltration problems that we haven't had in the past? Or are we going to go back to normal where it's not an issue? So that'll be something we'll have to look at past data, look at what we're predicting for the future, and really see how much money we want to put into the collection system to try to prevent that infiltration. And it's not going to be an easy answer, and it's not easy to get that data collected. So it'll be time consuming and expensive. So that's where we get to the $522,000 for the collection system master plan, which includes the modeling and all of that. So we also added in the water distribution system modeling. It doesn't really fit into the rest of the wastewater stuff, but the reason we added it as an EDA project is one of the things we've noticed through this is with the pipe being out of service, next to the chamber there, a 12-inch main. We really didn't have a way of predicting how that's affecting our service. It's caused us some issues in other portions of town with a lot of discoloration in the water. We're getting a lot of iron in the water. And we think that's because it's changed the flow of the water, or it's forcing more water through pipes that we normally didn't have that high flow. So we don't have a good way of seeing that and predicting how that affects us, which means we really don't have a good way of understanding what pipes are critical to our distribution system. With the modeling, we can evaluate that and see, especially on the creek crossings, so that when we have this event again, we understand which pipes are critical, which ones maybe are not critical, which ones are valved properly, valves on each side of the creek where we can shut the crossing off and not have people out of service, or do we need to add valves so that we have that capability? Again, what pipes do we need to look at in terms of crossings that maybe need to be replaced, bored new pipes in deeper so that we can protect our distribution system. But until we really have good information, it's hard to know which ones should be on top of our list. So again, it's a planning document that kind of gives us that option to understand where we're at and what needs to be on top of the priority list. So when you get into master planning, you really need to do a distribution model to understand where you need to be. And that kind of gets us to where we're at now. Again, all these numbers, again, are preliminary engineering numbers. We didn't have a lot of time to put these projects together. I'm happy we started the condition assessment as soon as we did, but it was still really a push to get these numbers in and get these projects in. So there's going to be a continuation of working through these projects with the ED application, verifying some of our numbers, understanding what EDA is willing to pay for, what they're not. So it's continues to be a very murky situation yet, and there's a lot to go through as we move through the process. But that's basically where we're at right now, is identifying this funding packages and seeing if they're there. Once we get beyond that, then we'll get into that master planning and determine what direction we want to go. If these projects would get funded through EDA, it looks like there's about a 4-year window to get these projects completed, 3 to 4 years. So some of these projects we'd be looking at getting into a preliminary design pretty quick. Right now, with the way we did this, we didn't go out for RFQs for the engineering. So currently our engineering is cannot be part of the EDA funds. So from this point on, as we move into design phases and things like that, we'll go out to RFQs for our engineering to make sure that the engineering is also eligible for reimbursement through EDA. So, and again, EDA is a 80-20 split, 80% grant, 20% match. So total of these projects, we're at about $9.5 million right now. Again, with those numbers, there's a lot of contingency built into that, especially on the wastewater stuff. A lot of times you're not sure what you get into until you get a little more in depth. So as we move through some of these projects, we want to leave ourselves plenty of room to maybe add a few little things as we need to as we go through these projects. Tanner, was there anything you wanted to add that I missed? Nick? Okay. So that's kind of where we're at right now. I know I went through that kind of fast. Again, it's preliminary where we're at, but that's kind of where we're at. We'll have a finishing up of the condition assessment here in a few months. We can bring that to you also, that final condition assessment. There'll be a technical memorandum that'll come out with that. We do have the EDA preliminary engineering report from HDR that we can send to you that will go over all this in detail, each project, the contingency costs and things like that, where we came up with those numbers. Questions for us? Concerns?
Wow, it's overwhelming. I don't know about you folks, but this is incredible infrastructure challenge. Couple things. So as far as engineering, you said you would look at that cost when you get to that point. Does that mean selecting?
Yes, we have an estimated cost for engineering in these project numbers. Okay. But in order for EDA to cover that cost, you have to go out and request for proposals or request for qualifications. Okay. before we do the hiring. You can opt not to do that, but then that engineering fee won't be eligible for EDA. Okay. So as we move forward, we'll do that request for proposals or qualifications to select engineers as we move forward.
Okay. And this master plan that you're confused on, I know that I'm familiar with the airport master plans where they're funded and they want it done. Is this important for the funding project, for having a master plan in place? I mean, it seems like if you don't have the data to go into it, then why put all the money into it if we don't know what the weather's gonna be like?
Right, and as you get into other funding sources, right now we're looking at the EDA funding. As we move forward in the future, some of these projects, especially if we don't get the EDA funding, we're most likely looking at SRF funding. And SRF funding does require a facilities plan. When you go to do that facilities plan, if you have your master plan in place, you've got a lot of your data done to prepare that facility plan. So the answer is yes, they will require advanced planning when you apply for these grants and these loans through
And
the
that's
state.
a state revolving fund?
That's
Probably
state
should try
revolving
to
funds.
Say some of these acronyms for all the thousands of people
I
watching
know.
at home.
I always forget that.
No, this helps though.
Yeah,
The
I-
EDA and
Yeah, Economic Development Administration, so.
the Influent, is that the generator that was proposed, is that portable? You said you could take it?
Yeah, it'll be a portable generator. And again, these are all preliminary
Yeah, I
designs. So
understand.
right now, what we're hoping for is a portable generator that can run those effluent pumps at the wastewater facility, but could also be used at the wells, Nebraska wells, or the booster stations on the water distribution side.
That's all I have.
Kyle, I guess if you could explain to me or help me understand, this $9 million project is just to extend the life of where it's currently at, correct?
That is correct.
So what does this buy us? And then how would that compare to, or at what point do we have to evaluate looking at something new?
I would say almost all these projects are what we consider immediate needs. They came out of the condition assessment as projects we're going to have to do short-term within the next 5 years. A couple of them, like the electrical system, adding some redundancy to our electric system could maybe be pushed a little bit. But most of these projects are projects that we feel are going to have to be done in the next 1 to 5 years, no matter what. Prolonging the life of the plant, until we get that master plan done, that's kind of hard to answer. But the reality is these projects are going to have to be done. That's where we're at with the conditions of the facility. As we move into getting that master plan completed, then we'll start getting that long-term view of, are we good for 10, 15 years? Where do we need to be? How much are we going to spend? And that's where we really start to answer that and look at that question. I shouldn't say answer, but look at the question of, is this a large project? Is this several small projects? Do we stay where we're at? Do we move? That's when we'll start looking at all those options. But right now, we're really looking at projects that need to be done in short term before we can make those long-term decisions. If that makes sense.
No, it makes sense. It's just a large bill to think about that it's only going to buy us some years compared to what potentially could be an overall project that lasts us the next 20 to 30, I guess is what I was getting at and asking about.
Yeah, I mean,
And I get obviously short-term and long-term needs
Right.
and that a lot of this is
Yeah.
short-term. And even if we would look at what's the cost or the opportunity to build something new, that's probably not going to be done in the next so many years
right.
anyway.
If
So
you look at the process of getting to building a new facility, by the time you do your master plan, do your facilities planning, apply for the funding, we're really 10 years out, best case scenario. So it's just a really long process to get to that point for a large project of that scale.
So hypothetically, Kyle, if you knew the plant was going to be moved completely, what would you do different short term? Anything? I mean, I'm just thinking, I think on the same lines as Commissioner Moser is wondering if, I know it's a thought in our minds is, do we spend this time to move it and build a new updated state-of-the-art facility, or keep on, where
There might be a couple projects in there that I would waver on, like the Equalization Basin. Do you really need to do that if you know you're moving in 10 years? But you look at the majority of those projects, especially on the electrical switchgear, the aeration pumps, they've got to be replaced. Most of this project is, again, short-term needs that we just are, that's part of doing business in this field. The infrastructure doesn't last real long. It's harsh environments. So it's, there's a few projects in there I'd probably maybe waver on a little bit. For the most part, these are projects we need to do in the next 1 to 5 years to maintain a reliable wastewater facility.
Kyle, this might not be a fair question, and maybe it's a question actually for Tanner, but if we had an event again like we did in March, and we didn't have our major manufacturers, which are high users out on the east side, cease production for a few days, and we hadn't had, our staff working, I think, around the clock for a few days, what would have we been looking at? I'm thinking that we kind of, even though we had a worst case scenario, we had a best possible outcome, but my understanding was that it could have been a lot more serious than that.
Yeah, when you look at the fact we estimated, and again, there was an estimate, that we estimated roughly around 3 million gallons that we bypassed around our facilities. If you don't do that and you start having your aeration basin flood, your lift stations flood, you end up in a situation where you're down for days and weeks to get that equipment that was flooded back up and running. So now you're talking millions of dollars just in infrastructure repairs that have to be made short term, quickly, at a high cost. So again, it was staff going in, setting up the bypass pumping, moving the flow around our critical infrastructure so we did not lose that critical infrastructure. So it would have been much more expensive if we wouldn't have done the bypass pumping and things like that. So does that answer your?
So being down for the common person, the end user that flushes the toilet, what does that mean?
That's a good question too. On something like a lift station, the option there is we have to bring in temporary portable pumps to pump that out. Otherwise, you're going to have backups into your homes and your facilities. At the wastewater facility, we have the ability to bypass to the river without having to pump it, but basically ends up with raw sewage going to the river, which is not looked upon very favorably. But on the lift station side, or failures in like a collapsed main results in backups to homes, businesses, which can get very expensive very fast.
Kyle, we had some problems in the past with our little biological or gazillion bugs working around the clock. How are they doing?
I got an analogy here, but I can't use it. The bugs, so far, I think we've had good luck this summer. But again, something like that equalization basin where we can level out that flow, maintain it at a level, just makes it easier for treatment to manage that treatment, and the treatment works better. So we're always looking at ways to optimize our system and keep the bugs happy. That's what Tanner does.
So during that event, we did have to bypass for a certain period of time, and we did it in order to keep that bacterial population in place. We didn't want to cause too much turmoil within that system, and so we bypassed as little as we could, but we also didn't want too much flow going into that bacterial basin and disrupting it and stirring it up and actually losing inventory out to the river that way. So that was part of the bypass as well. The reason for the bypass. It ended up being like 2 million gallons over 20 hours.
Yeah, we had roughly 2 million gallons at the wastewater facility, another 1 million gallons at a lift station that we bypassed.
So if we're unsuccessful in securing any EDA grant funding, where does that put us from a rate perspective? Are we going to have to look at a rapid increase in rates to cover these projects if we move forward with them?
Yeah, I was going to say.
It's not proverbial, I don't have a tree I've discovered that's growing cash, so it would be SRF.
life. They got to keep them. No, no. Yeah, I better not. Any other questions, concerns?
I have one, and I was thinking of a couple. On the other end of what Commissioner Hoffner brought up, if we wouldn't move it, my first question would be, does any of this $9 million investment play into, if for some reason the master plan comes back and we find out where it's located needs to stay, is there any of that 9 million that stays, or is it completely gutted and started over, so it's throwing it out? I guess I'll let you do that one, and then I'll think.
We're trying to pick projects here of things that would stay. Again, that without the master planning being done, like the aeration pumps we talked about, if we go to that dry pit submersible, we'll also look at a capacity need for the future. So we'd probably upsize those pumps as that replacement. So we try to take that into account.
And some of that could be moved to another location? Is any of that, I mean, some of it looked portable, some of it not.
Some of
Wouldn't
it could be
something you
moved to
reuse.
another
Okay.
location, but the reality is if you're moving to another location, part of the benefit of that is you can leave your existing sewer plant up and running the whole time you're building your new one. So most of it would not move. But, you know, like the Influent line coming to the facility would probably stay in place, because if you move that facility, you're going to have to put a big lift station there to pump it to your new facility. So you're never going to get away from all the infrastructure down there. So like that new pipe, you may remove the inlet building, but you'd be replacing it with a major lift station to get it pumped to the new facility.
Okay, then my last question, I'll be quiet. You mentioned the sinkholes. Is that really the only project that could be tied to FEMA grant, or are we still playing that out, and anything that we're talking about here could be tied to either or?
Most of this stuff, a little bit of it may qualify for hazard mitigation, but most of the FEMA funds pay for things that were damaged to restore them back to existing. Again, we didn't have that much damage. You know, most of it was time and energy to bypass everything, so we didn't have damage. There is some damage. Again, like with the sinkhole, we're not sure yet what FEMA is going to cover, considering there was a little bit of a pre-existing issue there. So that's all up in the air, but most of the EDA projects we picked out probably would not qualify for the FEMA hazard mitigation.
Okay, I lied. One more. For you or Tanner, if you took an entire year, all your hours you put it into an entire year, so kind of a stumper like Amy, how much would you say is spent piecemealing, making sure this plant stays up and running versus just doing the day-to-day job you would have if there wasn't issues?
I'll let Tanner take it. Tanner can better answer it, but
we do a lot of corrective maintenance, which means you're fixing things a lot. So I've got a full-time maintenance man, Greg Gusso, and he spends a whole lot of time fixing things. Where ideally you'd like to be in the point where you're just doing preventative maintenance, keeping up on equipment, making sure everything's running properly. But I would say most of his tasks are spent fixing things. And with the wastewater plant, you can't run it to failure. So a lot of these things just need to be done.
And the other thing I'd say about too is staff has found some very unique ways to repair things and keep them running. They've done a great job of maintaining our facility and keeping it running. It just gets to a point where you're beyond preventative maintenance. You're in that window of replacement. And that's where we're getting at with a lot of this equipment.
Kyle, are the projects that you're planning also taking into account potential increase in capacity? Meaning, hopefully we're going to grow, not just residentially, but more industrial uses on the east
Correct.
side as well?
Everything we'll look at, we'll also look at the capacity for the future, meeting those needs, and also we'll look at the regulation side. Will these things help meet our regulations in the future? We know we're going to have some future regulations with nutrient removal and things like that. So we keep those things in the back of our mind. We design for those. So when we say HDR designs those for us too, that we're meeting our future needs.
So with water, we'll be transitioning into a membrane system, which is newer technology than what we had previously. In the wastewater world, is there any new technology that we may be looking at for a new or updated plant?
Of course, yeah, of course there is, especially on something like the UV, like our UV system is outdated. The technology on the UV systems has improved greatly. Again, when we talked about nutrient removal, we'll be modifying our current basins most likely to meet those needs. That's one of the things we looked at when we went to the WEF conference last year. We spent a lot of time on the floor looking at different options for like inlet works, rather than having bar screens, maybe a mechanical grit removal system with a mesh system that removes more of the solids. So there's a lot of different options out there. We've got a long ways to go before we start making some of those decisions, but yeah, technology is always changing our field, especially on the control side. Looking at that in the future.
Is there any more education we need to do as for the public as far as the product? Let's say the finished product or the how has that changed? Or, I mean, sometimes we get out and have a little bit of press release on as far as the citizens to make sure that they can do what they can and what they should flush and not. Has the product changed? Or has that gotten better or worse? Or?
I would say the biggest thing right now that we're going to have to look at is the sump pumps and getting your sump pumps discharged to the storm sewer system, not the sanitary system. We talked a little bit about some of this stuff, but we're running about 2 to 2.5 million gallons a day right now. Normally we're 1.8, 1.9. So we're still getting a lot of infiltration into our system, and I'm sure a lot of that is coming from sump pumps. So we're going to need to push. We just haven't had time trying to get the EDA stuff and the FEMA stuff put together, but we're going to need to put a push on to educate our users that they need to get those sump pumps discharged out to the storm sewer system so they're not overloading our treatment system and all those extra gallons we have to pay to treat. So if we don't need to be treating them, we can save ourselves money by getting them out to the storm sewer system.
Are there any more questions of Kyle or Tanner or other city staff?
Great questions. Appreciate it.
Well, thank you, all three of you, for your presentation this evening. As I said, we had a lot of, I didn't say this earlier, but I'll say it now. We had a lot of crap to cover tonight. I've been waiting for that.
I've heard that one a million times. Right. Thank you. Appreciate your time.
And I'm sure you'll keep us updated. With that, there's no other business on this work session agenda, so we'll adjourn till 7 p.m. when we will begin our regular meeting. Can I have a motion to adjourn?
So moved.